The next one is subtraction. If I say we're going to add 5 plus 5, we're going to get 10. If I want to do my opposite of my addition, I'm going to do subtraction. So obviously I'm going to take one of the numbers and say 5, 10 minus 5, which will give me 5. So remember, if we always talk about the inverse of something, addition and subtraction. There are a couple. Okay, they will always be bonded together. To distinguish, we always will use the plus for addition and a dash, which will be for subtraction. Next is multiplication. Multiplication goes with who? If adding and subtracting go together, that means multiplication will go with who? Who's the multiplication partner? Division. Thank you. Aaron. Welcome back. Haven't seen you in a while. Okay. What we usually will see that is we'll have our equation in a set of parentheses, or we use an asterisk. Why don't we use x? Because I know in elementary and middle school you were taught for multiplication you use an x. But once you got into algebra, we started using an asterisk. Because x can mean what? Say that again? It can mean anything. It can be whatever number that they want it to be. So, we also want to make sure that we leave off with our final will be division.
Everyone's used that little.
So you got 4 different operations, 2 couples, and 4 different symbols. Now, the way that we will start, the way you will determine if it's a division is by using a fraction or sometimes the slanted dash. If you see, right here we use the slanted dash. Here we have f of x over g of x. Or if we said find f, take f problem f and put it over g, that's multiple. That's division. Sorry. Multiplication we use is what? The asterisk. Subtraction. Yes. Yeah, go ahead and just go get a drink of water. So we're going to keep moving on. Remember, these notes, you'll find the way to fill in your notes, because when you go to take your test, you'll be able to use your notes, but you won't be able to use your Google or search. So now we should be down where we're looking at the big box. It should say algebraic expression. So we're looking at, it says let f of x be 2x minus 1. And then there's g of x, which is 3x plus 4. Okay? So the first one we're going to talk about, what is my operation right here? What operation is A asking for? What's my operation? Addition. Addition. We already know what our problem is. We're going to substitute 2x minus 1 for everywhere we see f of x. The same thing for g of x. We're going to replace it with 3x plus 4. Now, there you go. That's the answer.
Like, how does the answer?
Well, this is when we fill in, when we replace f of x.
This is it here.
Yeah, you write it in the box. do that, I'll do it for you, okay? That just tell you the different operations. Addition, subtraction, multiplication, and division, what they look like.
Wait.
But you can, we'll get to it, okay?
Mr. Dillon?
Yes.
I'm still like confused, like, that, like, how you get that?
How did I get this?
Yeah.
Okay, everywhere I see f of x, right? Let x be, it's supposed to be f of x. Everywhere I see this, I'm going to put 2x minus 1. Everywhere I see g of x, I'm going to put 3x plus 4.
Oh, I did not see it.
And I said you're going to substitute it, right? Did I do it? Okay, I apologize. When I go ahead and substitute it, I can go ahead now and break it down. I can simplify it. You can leave it elongated, but you're taking up too much room. So I know that everywhere I see that I have a variable of x, I see I have 2x, a positive 2x, and a positive 3x. I combine those and I get 5x. I see I have 4 and a negative 1. So I say 4 minus 1 is 3. Guess what? That's your answer. You're done. Unless I tell you to solve for x, you don't have to go no further. You're going to stop here because our answer will end up being an improper fraction. We'll end up with 3 over.
I thought that was a positive 4 for some reason.
That is a positive 4
Oh.
and negative 1.
Oh.
I thought when two positive, it make it negative. Why the fuck on negative?
No, you're talking multiplication. So remember that rule of thumb when we talked about it. 2 positive multiplied makes a what? No,
Positive.
two positive. If I said 2 times 2,
That's 4.
but it's going to be a what? Type of 4.
Positive.
Negative.
Now, if I said negative 2 times positive 2,
Oh, negative 2.
no, it'd be what?
Positive 4, right?
No,
Negative.
negative 4. Now, if I said negative 2 times negative 2,
Oh, negative.
No.
Positive 4, positive.
positive 4. Thank you. Remember, those are the simple rule of thumb, the rule of thumb operation. Yep, 2 negatives makes a positive. Positive. Think about the number count. If I say a positive, I'm going to make 2 flashes, right? So 1, 2, 1, 2. So it'd actually be 1, 2, 3, 4. Right? Even. If I say negative times a positive, so 1, 2, 3. That's odd. That's a negative. If I say 1, 2, it's even, positive. Huh? Who's negative? In here? Okay, count the signs of you doing it like this. So I say 1, 2, 3, 4, positive because it's a 4. 1, 2, 3, it's odd,
Oh, we just talked about it.
so it's a negative. Negative times a negative is 1, 2, even. Wait, the wheel. Okay, now, for B, what operation are we looking for?
God, that Marcus was all subtraction.
Subtraction. So we're going to do the same thing. We're going to substitute it in, and we're going to this time subtract. We're going to substitute it in. So now right here, I have my 2x minus 1 minus 3x plus 4. Just like in the beginning, we talked about this. I'm going to go ahead and have to contribute. So, when I go ahead and I got my parentheses and my -1, I'm going to flip everything past that, in that factor, which are parentheses, into a negative. So that makes it a -3 and a -4. I can combine those. So -3 minus +2 is 1x, which we just write x, -x. -1 plus a -4 will get us a -5. C. C, what is our operation here we're going to be doing?
Multiplication.
What is it?
Multiplication.
Oh,
Multiplication.
multiplication, yes.
Multiplication.
Because remember, what symbol are we using right here? What's our symbol?
X.
Not an X.
Times.
Asterisk. Remember, X we don't use once we get into algebra enough because it can represent any number or anything that we wanted to say. So here, we're going to factor them. Factor means parentheses. So there's another way of saying factor. Remember, we solved it by doing our box method or FOIL. So I have 2x minus 2x, well, parentheses 2x minus 1, parentheses 3x plus 4. This is where some people like to do FOIL. That means first, inner, outer, left. That means we're going to be seeing it jump. This 2x will multiply to the 3x, 2x times 4. Then I will go -1 times 3x, -1 times 4. I put that all in my little special box, and then this is what you come up with. But, am I done right here? What can I do? What can I do? You're right, no, I'm not done. But I should be able to what? Remember, CLT. Combine like terms. I can combine, obviously I can't combine 6x squared because there's no other x squares. I have an 8x and I have a -3x. I can combine those. Either way, in the blue or purple is correct. I know exactly what y'all trying to say. Have any questions? Now, using those same factors or same f of x and g of x, yes.
We ain't doing D.
Yeah, we're gonna go to D. He has to go back.
It looks like some for the southpaw. You know, that guy,
You good to go? We can always come back and I can better explain it to you, okay? D. What is my operation I'm looking at for D?
Fraction, right?
Huh?
Find 2x of x.
So f of x over g of x is a what?
Fraction, right?
Fraction, but I'm talking about the operation.
Oh, division.
There you go, division. Fraction is not an operation. That's just how the problem is stated. So here we're going to have 2x minus 1 over 3x plus 4. That's it. I didn't tell you to solve it. I told you to just write it, okay? When we get to solving, that's when we're going to have to start to do the inverse flipping like we did last class when we were talking about radicals. We will get to this later down the line, but just right now, if you see algebraic expressions or function operations, I'm asking you to just write it. E. Now, what stands out different in E than it was in A? What's that?
It has a number now. It's a 3D.
It has a 3, and what else?
And X.
No, it still has an f of x and g of x, but what is in front of f and g? No, what's in front of f?
2.
And then what's in front of 3?
A 3.
G plus.
So this is how you, this is what it's saying. It's saying 2 parentheses 2x minus 1, and then plus 3 parentheses 3x plus 4. What am I going to do with 2 in the first term? I'm going
You gotta turn
to,
it to a negative, right?
no, it's a positive 2.
Subtracted.
Not subtracting it,
You added it.
Added.
not adding,
Multiply it.
multiplying it. So I'm going to multiply 2 times 2.
2x.
2 times 2x will be,
4x.
yes. Then 2 times negative 1,
Will be 2. Positive 2, right?
nope,
Negative.
negative 2. Remember, a negative times a positive is always a negative.
Oh, yeah.
So then I'm going to look at my second term. 3 times 3x. What is 3 times 3?
9x.
9x. And then what is 3 times 4? 12. That's what I want to do. Okay? I got you here. But I can go ahead and CLT, combine like terms. I know that I can combine 4x plus 9x, 13x. And then I see my plain constants, I have 12 minus 2.
Hold on, wait. Where that?
Like this. Yeah, they're all hyped up. They said we get a bigger snowfall from the north to the south.
It's going to be snowing in Detroit. Is it
Also
snowing?
mentioned that we got enough in the.
Is it snowing in Detroit?
Yeah.
It's off the Great Lakes.
I'm not from here, bro. I'm from Baltimore. Sorry.
Born and raised in the city.
Y'all remember learning geography of what is the Great Lakes nickname?
No.
Holmes. Hudson, Ontario, Michigan. What was he? In Superior. I forgot what he was. The 5 lakes up there.
I won't go to Michigan, though.
It snows like every day. My son got snow up in Cornell, and he's right off the Finger Lakes. Yeah, up in Cornell, Ithaca, New York, upstate. Yeah. Okay. While we're looking up the geography question. Okay, so we're doing the same thing, but this time instead of us adding, we're going to be doing subtracting. So once again, we do the same thing. We replace our f of x and g of x. But now, we see that our 3 is no longer a positive 3, but a negative 3. We distribute it out. That should be negative 12. Actually, we distributed the sign, but we're still not done. Because what happened is when you see what happened, what I did was on mine, in red to blue, is I kept the negative sign outside of the parentheses, but I didn't distribute, inside. So 3x was the same thing as over here, 9x plus 12, and then I distribute the negative sign to negative 9x and negative 12. You get it? But you don't get it.
It's Erie.
Erie, that's what it was. Erie, right off of Erie, Pennsylvania. Erie. So it was Hudson, Ontario, Michigan, Erie, and Superior. Those are the 5 lakes that's why Chicago and all of them have a lot of stuff. I do too. I gotta go home and get my snowblower up and running. So 1 year, I had surgery done on my shoulder, and my wife had carpal tunnel surgery done. So, neither one of us did a lot with shovel. And the doctor said, listen, I'm giving you a note to write on the snowblower so that you don't have to shovel snow. So I went out and looked. I'm talking here, you know, I'm going up and down the neighborhood. So people were like, you know, come back and went,
I really couldn't hear it.
I had to go get my mother.
Oh, shoot.
I get there. Got so anxious. I ripped the spring out of the snowblower in the middle of the snow. We owned it for less than a day.
Look, Miss Denny, can you go back with me?
Okay, go ahead.
Can you go back with me, Miss Denny?
I pulled this thing. Took it right back to the room, that same thing.
You think like
You
they technology on it?
You already did this.
They said they
So
technology.
then, after that,
Look at this.
we waited until after the snow season, and then we're both big, giant tree good.
He bought me.
So I bought 24 inch. My brother-in-law.
You think I'm an immigrant?
I just want to
skin color.
but now I have to.
Look at my skin.
Over this gate and came here.
It works out great.
Look at my skin.
I split her out.
I'm born in-
He black
I go to my neighbor that was older.
My last name's Lawrence.
That's good.
That's a big
Okay.
name.
Your last name.
Here we go.
Chuck.
Hey, be quiet, everybody, please. Using table, graphs, and equations. What does that mean? Okay, we're talking what we used to do. When we look right here, we see a what? Is this a graph, table, or equation? What is
It's a
this?
graph.
That's a graph. That would give me my what?
Table.
And then we have our equation. So, at the bottom, it tells us that we're going to need to go where it says f of 0 minus g, g3. So, we know that this is f, this is g, this is h. So, I'm going to find out wherever my 0 is, where is my point? I see my point. 0, it's at intersection of what?
Two, right?
2. 2. And then for G, I'm going to go where it said 3, and then I'm going to look over to the right and I see,
Positive 4.
yes. Now, for right here, it says H times what? F. So that means this equation times that equation. We'll get you a little bit more.
I'm confused.
Right there.
Where are you confused at?
I was, this is,
So wherever I see H, I'm going to replace it with 3x minus 5 times, what is my equation for 4?
equation for
That's
3 7.
4x,
Wait, what you got for that?
because where my point's starting at. Negative 4x. Uh-huh.
Oh, okay, so that's what we
That's
started.
my starting point. Negative 4x, and it's going up. So then I would say to 0 plus 2, because that would tell me from 4 to 2 is my next point. Minus times negative 4.
Yeah, I'm not getting a good grade on this.
I don't want y'all to stress on this, okay? Don't stress on it. This is only a prequel to what we're going to get into much deeper. So please, do not wrap your head around that you must get it all in one swoop. This is the point of why we go to school, and you start off in class at the lowest level, and you keep building up those stairs, okay? We're walking up these stairs. It's like over 4 years. You got when you go to graduation, there's going to be 4 steps. Your first one was your 9th grade year. Your second one was your 10th grade year. Your 11th was your 3rd one. And then you make it to the top of the stage. That is your 12th grade year. Walking across this stage, getting your diploma, means you accomplished what you set out to do. And this is less like the same thing. We're building to those stairs with this math, okay? So don't try to swing for the home run. Okay? They always say, what win games in baseball?
Practice.
Not practice. If I hit 3 home runs, but my team has 20 hits, those 20 hits can add up, right? Step by step by step by step. We ain't showing Tommy the